Good evening, ladies and gentlemen. Welcome to the Victoria Memorial Hall to what we are looking forward to as a very exciting and mysterious talk on the history and mystery of calendars by Professor Palash Baran Pal, eminent author, linguist, and Emeritus Professor of Physics, University of Calcutta. He's possibly going to touch upon various types of imaginations and thought processes that have gone into making of calendars over certain periods of history. And this is a very fascinating subject, we thought, so that we could also learn a lot of things from his experience of researching on this subject. So I would like to request Dr. Jayanta Sengupta, Secretary and Curator of Victoria Memorial Hall, to welcome the audience, after which we'll have the lecture.
Good evening, everybody, and a very warm welcome to this evening's lecture on the history and mystery of calendars, which will examine the main problems of calendar making and how people in different civilizations have tried to solve the problems of calendar making. And it's a privilege and an honor to have with us here tonight to speak on this subject the eminent physicist, author, and linguist, Professor Palash Baran Pal. As a scientist and author, Professor Pal needs no introduction to this audience, but because this is a formal occasion, I will just say a few things about him. He is one of the most distinguished theoretical physicists of our time, but he has also been, for a long time, one of the most influential figures in the spread of public knowledge about science through his popular writings. Indeed, it won't be incorrect to describe him as one of the very few polymaths of our time, who has chosen to work and write on science, literature, language, and many other things, and have chosen to explore their interconnections as well. Professor Palash Baran Pal, who is currently Emeritus Professor of Physics in the University of Calcutta, was educated in the erstwhile Presidency College, now University, the University of Calcutta, and Carnegie Mellon University at Pittsburgh. He has previously been a professor at the Institute of Astrophysics at Bangalore, and for 2 decades at the Shah Institute of Nuclear Physics in Calcutta. He has also had research and visiting faculty positions in many other universities all over the world, including the University of Maryland at College Park, the University of Massachusetts at Amherst, the University of Oregon at Eugene, the University of Texas at Austin, the University of Puerto Rico, the École Polytechnique in France, the Instituto Superior Técnico in Lisbon, and the International Center for Theoretical Physics in Trieste. He has published several academic books on physics, whose titles I will not read out here because I don't have the knowledge of physics to even pronounce some of them correctly, so I will desist from that attempt. But as I said, he has also written extensively in Bengali as well as English for the popularization of science. Among his most popular and influential books are Ki diye sob kichu gora, Ki diye somosto kichu gora, What Everything is Made of, Shal Tarikher Itihash, A History of Dates and Years, Bigyan, Bekti, Jukti, Shomoy, Shomaj, Science, Persons, Arguments, Time and Society, Map Joker Itihash, A History of Measurements, Einsteiner Uttoradhikar, Einstein's Legacy, Shutropat, which was a Bengali translation of Isaac Asimov's Beginnings, Alor Kotha, On Light, which was written for children, and many, many others. He has also translated poetry from the Spanish, French, and Japanese languages to Bengali, including one of the first Bengali translations of Pablo Neruda's poems. Professor Pal has won the Robindra Shriti Puroskar in 2004 and the Ramendra Sundar Shriti Puroskar in 2011 for his books on popular science in Bengali. And that's all I have to say for now. We are very thankful and honored by Professor Pal, in spite of his very busy schedule, to agree to give this talk here. And typically, when I requested him for possible topics, he gave me, I think, 11. He very carefully chose a prime number out of which we we chose this one, the history and mystery of calendars. So, like all of you, I'm looking forward to listening to a very fascinating lecture. So please join me in welcoming Professor Palash Baran Pal to speak on the history and mystery of calendars. Thank you very much.
Before Professor Pal takes the microphone, may I request Jayanta Sengupta to kindly offer him a small token on behalf of the Victoria Memorial Hall. One request to the audience, the calendar that you people are used to looking into nowadays, which is within your mobile phone, if you could put that calendar on silent mode, please, for the duration of the lecture, we'll be very thankful. Thank you very much.
Thank you very much. I'm really grateful that Jayanto, Sengupta and others who organize these seminars have asked me to give this talk. I feel very honored to be here. I should also say that I am also a little bit afraid of one thing. I am really afraid of giving talks. I'm not afraid of the audience. Whatever you do is fine with me. I will not look at. But the thing I'm afraid of is that there is no clock in this room. So it's always good to have a clock so that the person knows, the person giving the talk knows when to stop.
But we can always enjoy the mystery of calendars.
Okay.
You see, we will perhaps put one light on.
No, actually, I have made an alternative, but it's good. I mean, you know this story that once somebody came and asked Sharachandra Chattopadhyay that there is a very great exponent of classical music coming to town, and whether you want to go to listen to him. And Sharachandra said, "Okay, I understand this is great. He sings well, but does he stop?" So it's better to have a clock, or at least a calendar, so that I know which day to stop. Okay. Anyway, that brings us to calendars. So, as you see, the title of the talk is The History and Mystery of Calendars. And according to the rules of the time, I will start with a commercial, some publicity. This is the book, Shaltarikeর Itihas, which contains almost everything that I'm going to say today and much more, because I cannot possibly give the entire book in a 1-hour talk. On your left, you see the Bengali version, which is now in the 3rd edition. On the right, you see the English version. The English version is a translation of the 2nd edition of the Bengali book. And of course, the 3rd edition of the Bengali book is much better than the 2nd edition. So the advice is that if you know Bengali, read the Bengali book. And if you don't know Bengali and know English, learn Bengali. Before I go to the subject matter of the talk, I should point out to you some notations that I am using in presenting the talk, some conventions that I am using in presenting the talk. The most important thing for you is this thing. If you keep your eye on that, you will know how much of the talk is left, how much more you will have to survive. Okay? And if you fall asleep, before you fall asleep, see what is the number there, and when you get up, you see what's so then you know how much you have missed. The second thing is the background. The background, as you see now, it's a black background, but the color of the background will change. I will not mention it. I will not point it out to you. You will have to be on the lookout. But the change of the background color will mean like going to a new chapter in the book, okay, it's on a different topic, maybe on a different calendar, okay. So with that introduction, now I go to the subject matter of the talk. What does a calendar do? The calendar measures days into months and months into years. That seems like a very simple and very easy sentence, but actually it's a very, very loaded sentence, because I have used 3 words in this sentence which need some explanation: the day, the month, the year. What do we mean by a day? Well, you'll say, oh, that's easy. A day is the time taken by the Earth to complete one rotation around its axis. Very well, but the problem is, how do you know when exactly one rotation is completed? You see, when the Earth was created, if a bell was put on the Earth so that after one rotation it will do a ting sound, then we would have known very easily. But that was not done. So the question is, how do we know? And before I answer the question, and let me also tell you that I will not answer all the questions that I will raise here. It is important to sometimes to know the problem, and most of the answers are there in the book, but here I will just present the answers which will be needed for the subsequent portions of the talk. The other unit of time is the year. And the year, again, you will say, is the time taken by the Earth to complete one revolution around the Sun. And I will ask the same question: how would you know when exactly one revolution is completed? Now, between the day and the year, there is this other unit, that's the month. And for us, the definition of the month is determined by the paycheck. A month is a very convenient unit for getting paychecks. But what is the actual astronomical definition? The month is actually the time from one full moon to the next, or one new moon to the next, whatever. Okay? Now, notice that I haven't said that it's the time taken by the moon to go around the Earth once. I have not said that. That's actually a different thing than what I said. Why is it different? Let's look at this picture. In the center, you see the sun, and these things, the little green circles, they are the positions of the Earth at different times. The Earth still looks green from outside. That's why I have painted it green. Another 100 years like this, the Earth will look gray. Okay. And then this other thing is the moon. So when the Earth is here and the moon is here, let's say, then the moon is getting the light from the sun, and we are seeing the lighted half of the moon, so it's the full moon. Then the Earth is going around in its voyage around the sun, and let's say when it comes here, then the moon is between the Earth and the sun. So then the lighted part of the moon is away from us, so we don't see the moon. Now notice that going from here to here is not a rotation of 180 degrees as far as the moon is concerned. It's more. And more because the Earth has shifted. So when the moon has completed 360 degrees, as in here, it will not be another full moon, because the Earth has shifted and the moon is not in the line of the earth and the sun. So the full moon will happen a little later, when again the moon will come behind the earth. So you see that it's not 360 degree, as I said. And the time taken from A to C, that is the 360 degree time, that is called the sidereal month. Sidereal means about the stars. So the moon is seen in the background of stars to complete a 360 degrees, and that's the sidereal month, and the length of that month is roughly 27.3217 days. But the time from A to D, that is the full moon to full moon, that's called the Synodic month, and that's 29.5306 days roughly. That's a huge difference. Okay? So when we will talk about month, mostly we will talk about the Synodic month, because this is the one which is easy to see. It's much easier to see the full moon than to see 360 degrees on your sky. Okay? Now, here you see lies the basic problem. You have already noticed that when I was talking of the lengths of the months are not a full number of days. And that is true for all pairs of the length units that we have, time units that we have encountered. 1 year is not exactly a full number of days. It's 365.2422 days, which is like 365 days, 5 hours, 48 minutes, 46 seconds. 1 month, as I said, is a synodic month, is just 29.5306 days. And if you divide the two, then you will see that 1 year is 12.3683 months, which is 12 months, 10 days, 21 hours, etc., etc. And this is the main problem of making a calendar, of constructing a calendar. How do you manage the fractions? You cannot possibly tell people that, okay, a new year will start at 5 o'clock or 17 minutes after 5 o'clock tomorrow. That you cannot tell. You will have to start a new year or a new month on the beginning of a day. But these are not full numbers. These are not whole numbers. So how do you manage these fractions? And the answer, in very short answer, is that you manage it by intercalation. I will explain what intercalation is, how it is done, but just a short explanation is that you basically insert some things periodically so that the fractions are taken care of. One example is 29th of February. Okay, you insert it sometimes. So, because of this different strategies for making things work with whole numbers, there have developed 3 main calendrical systems. Number 1, solar calendar. Solar calendar keeps solar years. The months are just convenient subdivisions of the year. As I said, it's just for getting the paycheck. The month does not attempt to correlate the phases of the moon with the days of the months. For example, today being 8th of August doesn't tell you anything about how the moon will look like in the evening. So examples of solar calendar, the Gregorian calendar, which is now the international calendar, the 8th of August, I said, that's the Gregorian calendar. The Bengali calendar is a solar calendar, I'll talk about it later. The Tamil calendar is a solar calendar. I will not have time to talk about it very much, but it's very similar to the Bengali calendar. The second system is called the lunar calendar. The lunar calendar keeps the synodic months. Now, a year is equal to 12 such months. Now you remember, synodic months is roughly 29 and a half days, 29.53 something, 29 and a half. If you have 12 such months, that will make 354 days. That's not a solar year, but that's the lunar year. Lunar year is 354 point a little bit because it's not exactly 29 and a half. So a year is equal to 12 such months, and there is no attempt to correlate the month of the year with the season. So if you have the month of Ramzan going on now, that will not tell you which season it is. Okay? Now, example of lunar calendar, well, I have in a sense already given out the example. The Islamic calendar is the lunar calendar. And in fact, as far as I know, it's the only lunar calendar which still exists in the world. The third type of calendar, which is sort of in between, is called the Lunisolar Calendar. And just from the name, you can understand that it sort of respects the sun and the moon, both. In what way? That the months are synodic months, just like the lunar calendar.